Okay, so the first one, we're given two 45, 45, 90 right triangles and one of the hypotenuses. So we have, the hypotenuse is 10. So we're always comparing to this default, sort of the general case for a 45, 45, 90 right triangle, where you know the two sides and the hypotenuse. So whatever the side lengths are, the hypotenuse is just the side length times square root of 2. So this first one's actually easier. Or sorry, the second one's actually easier. Let's look at the second one real quick. The second one is this. So in this case, you're given the leg. So if you're given the leg, then it's much simpler because you know this is 7. And if these are 7, then this is just 7 root 2. So if this is 7, then that means this is 7 as well. And this side would be 7 root 2. Okay, so this would be, actually I'll copy this. And then this side would be 7 root 2. Okay, so now we know this side, and if this side is 7 root 2, now we have this 45, 45, 90 right triangle, right? So you can look at this one. Whoops. And in this case, this is 7 root 2, which means that this is 7 root 2, which means that this one would be, whatever the side length is, the hypotenuse is whatever the side length is times root 2. So it would be the side length, 7 root 2, times root 2, which just comes out to 7 times 2, because root 2 times root 2 is 2, so 7 times 2. So this is really just 14. Okay, so number 2 is a little bit simpler actually, because you're given the side length. So when you're given the side length, it's easier to go to this situation. Okay. Number 1, you're given the hypotenuse, and it doesn't involve square root of 2. So if this was like 10 square root of 2, then it would be pretty simple. We would be like, okay, well that's 10 square root of 2, so obviously this must just be 10, because we know the hypotenuse is something times root 2. The side length is that something. So this would be 10, whoops, this would be 10, and this would be 10. That's not the case though. So the case we have is just 10. So we need to write 10 as something times root 2. So we want to write 10 as 10 equals something times root 2. Once we know that thing, we'll know the two sides, right? So 10 equals something times root 2. What times root 2? So we need to factor out a root 2 from 10. So to do that, 10 over root 2, right? Hang on, I have to draw this. 10 over root 2, 10 divided by root 2 times root 2 equals 10. So to write 10 as something times root 2, you'd write it as 10 over root 2 times root 2. Okay, so now we have this written as something, whoops, something times root 2. If we have something times root 2 for the hypotenuse, then you know that that something is the length of the legs. So 7 and 7, the hypotenuse is 7 root 2. So we had 10, we need to write this hypotenuse as something times root 2. So factor out a root 2 from 10. You get 10 over root 2. So then the side lengths would be, whoops, boom, okay, 10 over root 2. Nope, sorry, it's not the greatest way to do this maybe, but okay. So the side lengths would be 10 over root 2. So that side's 10 over root 2, and this side is 10 over root 2. Okay. So hopefully that makes sense. And then now we want to find x. So now we have this triangle. So it says at the top, multi-step problems, and this is why. So that was step 1. Step 2 is looking at this triangle, where now this is the hypotenuse, right? And we want to find the legs. Whoops. So to do that, we should first simplify this. So simplify, get the radical out of the denominator. So to do that, we would multiply by root 2 over root 2. So multiply the fraction by 1 in the form of root 2 over root 2. And then this simplifies to root 2 times root 2 in the denominator is just 2. So this would be 10 over root 2 square root of 2 . Oh wait, no, sorry, no square root, just 2. So 10 over 2 root 2. So we simplified this by getting this out of the denominator, multiply by root 2 over root 2, so 10 root 2 over 2. 10 over 2 is 5. So this would be 5 root 2. Okay, so now we have 5 root 2, and that is something times root 2 as the hypotenuse, which makes it nice and easy to find the legs. So the legs of this would just be 5 and 5. All right, so they're multi-step problems, and might seem like that took a lot of work, but it's the kind of thing like once you get the hang of it and you practice them, they actually go a lot faster. So the first couple can go kind of slow, but once you get the hang of it, you'll start to recognize these situations. Like, okay, I have the hypotenuse is something times root 2, so the legs are whatever that thing, the multiplier on root 2 is. In this case would be 5. Okay, this video is almost 9 minutes long, so I'm going to stop it here and maybe do another one for other problems.